we have just proved that Pythagoras theorem theoretically, right? And I have shown you it by this paper cutting and folding method also, right? How by paper cutting it is equal. Now as you know in Pythagoras theorem, the square of the hypotenuse, that is our hypotenuse, is equals to the sum of the squares of the other two sides of a right angle triangle. These are the other two sides of a right angle triangle. Yes or no? Now, I have mentioned here area of the square. You know the area of the square is side square. So for this portion, the area is this square. For this portion, the area is this square. And for this portion, the area of this square. Okay, so practically what does this Pythagoras theorem states? It says that the area of this square is equal to the sum of the areas of these two. Now to explain this one practically, now we have an apparatus here. Okay, if you see this apparatus, it is based on this only. Now you can see this is a bigger one now. This square is a bigger one, right? And here the sand is inside it. The sand is actually indicating the area of this big square. Now this sand will be equally distributed in these two small squares, indicating that the area of this big one is equals to the sum of the areas of these two small. Now if you see, if I just try to put all the sand into the small boxes, see this part is already filled, but still remaining some here now, and the sand, some sand are still here. So if I tilt it, okay, and try to make it equally distributed, see this whole sand, it is now into small boxes, right? Indicating that the area of this big square is equal to the sum of the areas of two small ones. Okay, so this proves this Pythagoras theorem practically with the help of this mathematical model. Okay, understood or no? Okay, thank you.